Hello everybody, this is Pete from PA Labs, and today we're recording the video for Chapter 7 Part 2, and it's a little bit more than that. But I wanted to point out, and this is from our arcade game, I want to point out that we're almost done. We're doing really good. So there's not a lot more to the pure basic half of the book. And the second half of the book is actually building the arcade game. So this is all the knowledge you need to know so we can go into building the game. And there'll be more learning there. So today, the biggest piece of this is going to be lists versus arrays. And they are very similar. They both are A-R-E. Sorry, I can't spell. That's a prerequisite of being a programmer. I mean, that's why spell check was invented, because none of us can spell. Okay, so both are zero-based. Both can be sorted. You can sort arrays. You can sort lists, even structured arrays and lists. Both must be freed, and I haven't talked about that yet, and that'll be part of this. When you create an array and when you create a list, a chunk of memory on your machine is set aside for the list and the array. And when you're done using it, you got to reclaim that memory. And that's the act of freeing the array or list. Both are extremely fast. I suspect arrays may be a little bit faster than lists, but lists have a whole lot more options for you. In lists, you can delete elements. Lists can be reordered, so you can move record 2 to record 1 or record 1 to record 12 with no problem. Lists can be merged, lists can be split, and there's a whole lot more. So let's take a look at these lists. Let's build a structure. Okay, so we got our structure bullet. That's that old hat to you at this point. And then I'm going to create 3 lists. So we say new list, then you name your list, and then you define it with a type. Well, I can define a list as string. I can define a list as integer, and oh, by the way, capitals don't matter. Lowercase is normally the syntax for this, but basic is very forgiving. Or lists can be structured arrays. So not a big deal. And notice we're not giving it a record count, because initially you've defined a list and you haven't put anything in it. So your list is 0. The number of the size of your array is 0. Let's go ahead and prove that. And let's say end there. And if I run this, oh, you're going to be mad at me about stuff later on. Doggone it. That's true. I have all kind of stuff in here, so we're going to have to deal with it as we deal with it. All right, let's see. We'll get to running this shortly. So anyhow, if I debug list size bullets, and that's this guy here, this would at this point return 0. All right. So now how do we add records to lists? So down here, we're going to add an element to my list. And then we're going to say my list is George, because this is a string. This my list is just a string array. And then I add another element, and then I say, hey, I want to set that one to Martha. If I want to add an element to the structured list bullets, then we would have bullet, add element bullets, and then bullets name, bullet speed, max distance, image, all of that. Now, why did that get upset? Oh, I renamed pieces of my array, didn't I? Let's see. Name, speed, max distance, image. Name, speed, max, image, distance. Well, that's definitely not it. Well, all we can do is run it and see what happens. 1, 2, 3, 1, 2, 3. Okay. Bullets is not a list. What did I spell wrong? Well, bullets. Oh, is this? Oh, yes, that's true. Okay, we haven't gotten here yet. I'm going to comment this out because that's a different lesson into itself. That's why. Okay, so when we do, here, let me zoom this up. Oh, where's my cursor? I lost it. There we go. There we go. Okay, so if we come up here to the first print, list size of bullets, the answer is 0. If we add two elements to George, we add George and Martha, and then we add an element to Moab. List size bullets. Why would list size bullets be 2? New list bullet. Add element bullets. Did I screw up? Oh, I sure did. Look at that. Ha ha ha. Okay, I listed my list twice, and this should be bullets. B-U-L-L-E-T-S. And get rid of the other parent. Okay, this will go right. There we go. So that's correct. We have two names, George and Martha, in list, and we have one bullet in bullets. Okay, now let's go ahead and get rid of that end. Hold on, let me put it back, because my idea on this was to do things in pieces for you. So let's turn on this end here and say, okay, I'm going to select element my list 1, and let's debug my list. So this is going to say print it to the debug screen. So in your head, decide who we're going to see, George or Martha. All right, and then we're going to run it. And I'm hoping you are correct with saying that we were going to see Martha. Why do we see Martha with record 1? Well, because it's 0 based. So George is 0, Martha is 1. But our list count is 2. Isn't that interesting? That's why we always have to say -1, list size -1, because this counts the physical items, and they are numbered inside the list as 0, 1, 2, 3. The count would be 2. Okay, so hopefully that all makes sense. Now let's go ahead and get rid of this one. So if we're going to delete an element, we can delete an element, my list number 2. And, well, that will be interesting. I'm hoping that kicks me back an error. Right? Shouldn't that kick me back an error? Because we have, we're telling him to delete record 2. He didn't kick an error, but he didn't delete anybody either, did he? Because we're 0 and 1. We told him to delete record 2, but it's okay that we deleted record 2. It just already didn't exist. We can only delete records 0 and 1. So if I say, oh, let's do this. If I say delete record 0, then I'm going to delete George, right? So then now, if we reprint the list size at the end of this, and then we say select element, hold on, let's come in here and say let's select element list size -1. Right, we can say, well, let's do it this way. List size -1. Select element, debug, next, right? So we're going to iterate the entire collection. after we delete that record. And we're going to print off, I would assume we know who we're going to print off. So we're deleting 0, which would be George. So the only thing that really should print would be Martha. Oops. A list is expected. Oh, poo. I did a double list size, didn't I? Okay, so we have, I think, one too many parents. Okay. Let's see. See, now we have George and Martha, but we don't have a Martha anymore. Why do we not have a Martha? Oh, we deleted. Oh, wait. I know why. We're saying I have this wrong. That's why it's upset with me. Okay, my bad. Scratch that. Delete is just this. We have to first select element. Let's see. My list 1. All right, so we're going to select element 1. So if we got an indicator on the side of our list, we've selected Martha. Now we're going to delete Martha, and so this will delete George. So let's go ahead and say delete 0. So we're going to delete George, and we should see Martha. And sure enough, we now have a Martha there. See that? So that's how you delete. It takes multiple lines to delete. You got to select who you want to delete, and then you can delete him. You can't reference based on a, I'm not sure why that wouldn't have given me an error. That should have given me an error. Let's go look at delete element. Ah, he was expecting a flag. Okay. Okay. Well, all right. There was an optional parameter at the end of that. All right, so that is how you go about deleting. So now let's iterate the whole list. If I iterate the whole list, let's put our stop here. And now let's run it. Oh, well, I guess I did that already. I guess I'm going to skip this, huh? All right, let's move down here to the next. Let's take this off. I don't really want to delete George yet. Okay, so now we're not deleting. Okay, so now let's come down here to touch on scope. This is kind of important. All right, let's put this back. And so I'm introducing you real quick to a procedure. A procedure, as with most commands in Pure Basic that are a grouping of things, is you have a procedure and end procedure. So you can see the blocking of the code here. Now, I'm declaring the name my procedure, and if I had elements here, I could put in elements. We'll get to that later. What we're going to do is say for X, we're going to iterate our bullets and debug our bullet. And actually, we would probably want to say bullet name. How about that? We'll debug our bullet name. And then, how do you call a procedure? Well, you just call a procedure. It's a procedure name in this. Oftentimes, procedures are also referred to as functions. And functions can return values, or they don't return values. So, at this point, we are not returning a value. So, do you think this will run? Now, we have defined our bullets up here, so it's defined in our code sheet. We have a procedure. We can see right here, this tells me that, the IDE understands what a bullet is, but let's put our stop in. This will error. Bam. And it says bullets, the list bullets, is not a function, array, list, or map, or macro. It has no idea what bullets is. And this brings up a concept of scope. Okay? So, when you define something, anything in Pure Basic, it lives in that scope. All right? So, for this, for all the code that's not in some sort of procedure, everybody can see that. Now, you have two options. You have a global. So that would mean everybody anywhere in any code sheet, in any procedure, everything except modules can see this. Which I guess is not quite really global. So that will work. But you really don't always want every piece of code in your project to be able to see something. Sometimes you want your scope to be unique. So most of the times I will build, there are reasons for global, and we'll be using global, but let's show you how that this works, right? So global, because it's global now, inside the procedure, we can now see Moab was printed, okay? So Moab is down here printed, so that's awesome. Now I take this off, our code won't compile. So for here, I can say shared, what was that? Bullets. Okay. So now I have shared bullets into this procedure, and just this procedure can see it. A secondary, if I had another procedure, I'd have to share it into that one if I needed it. And this will work as well. Okay? So we have to tell this procedure about it. Everything inside this procedure is almost like a separate program. So I could actually come in here and define an array called bullets of type string. How about that? And then this would be legal, but this sure as heck wouldn't, would it? We could have to do this. We could say this is an array, right? So we would say bullets 0 equals hello world. Now, that's kind of freaky to have two different things. Syntax error. What don't you like? Oh, sorry. Crap. That's mine. Dim. Duh. Okay. So, here we go. No? Oh, you need a number. God, I use lists way more than I use anything else in the world. Oh, that's true. This is not a list size. 0 to 9. How about that? And that's true too. You can't do this. We have to change this to be X, right? And so there we go. We have hello world down here. We do not have Moab. So we have managed to define two different variables of the exact same name with different types, and each lives in their own scope. This does not live past this end procedure. Okay? Everything defined inside here does not live outside of here. Things that are defined outside of the procedure cannot be used in the procedure unless it's defined as global or that you share it into the procedure. Very important concept. We will be using this heavily. Okay? So, move on. At the very end, I'm coming down here and freeing all my lists. So, and that reminds me, this is an array. I need to free array. Otherwise, what we have is a memory leak. All right? Now, the important thing about memory leaks is once your program ends, all your memory is reclaimed anyhow. But until that happens, every time we would call that procedure, we would create yet a new array of bullets over and over and over and over in memory without ever getting rid of the previous copies. And it is feasible that you will use up all of your memory and then your program will crash. And that's the definition of a memory leak, where you define something and don't clean it up. So it's always good practice that if you create something, you clear it. Okay, so that's an awful lot of material. Let's move on. Inheritance. This is the other piece of structures. So we're going to define a structure called location, which will have X and Y coordinates of where is something. What's the point? Okay, the point on the screen. Now, this could be a row column in a map. You're on row 5, column 12, or something like that. And then we define ship, or ships. And then we have position of type location. So now in the middle of this, I have this structure inside a structure. Everything's beautiful. When I go to reference that, this is cool. So we can say define, I don't know, as type ship. Okay? And that's just a variable. So now we can say, GGG, well, the case doesn't matter. So we can come into here and look, here's position, and then I have X. So we've just gone down a new level, and we do this. I can also play with position as its own animal. Okay? So this is actually something that is a enclosure of just these two fields, and I can pass him around that way. So just keep it in your head. So now that's kind of like inheritance, but it's not really. It's close. It's defining a user type and then using a user type. Now, if I define a structure called freighter and it extends ship, then we can come, oh, I ought to leave this. Hold on. This won't be bad. So position X equals 7. All right, so down here, I can define a freighter. Oh, goodness, my dogs are barking. So we're going to be really creative with these. F-R-I-E, right? No. E-I. Okay, there we go. Of type freighter. And now we have a freighter. And, okay, we added cargo. Well, cargo is one field, but then we have all the rest of these. We can go position X. So this freighter extends ship. So all of these fields are automatically inserted here. They're hold on. And you get it without typing it. Okay? So we can define scout. Same exact thing here. Define SSS.scout. Okay. And then we can say SSS. Oops. He's not a scout. Well, he extends ships. Sorry, my bad. So then he extends this guy, so then we get X again. All right. So we can define lists. We can define arrays. All of that works. So a word on naming real quick, because I'm kind of blowing through this because I believe this is getting long. Ships. There's a tendency that you will have to say ship name. Don't do that. Call it just name. Otherwise, you'll end up with ship name, ship size, ship position, ship engine, ship weapons type, ship armor, ship shields. Well, you're already referencing that this is a ship. Why isn't it just name? The ship's name. The ship's, okay? You see that concept? There will always be a tendency, and I screw up every now and again and do it myself, but try to keep that in mind with naming. And I have one last piece to this, is code organization. Well, all right, I'm going to move this to the next lecture. Okay, so that concludes the 7 part 2. I am not going to go through the 2 code sheets that came with this. I've fixed them. You can review these yourself and see what they're doing. I've already shown you all of this in spades up to now. So you should be able to easily go through that code and see what they're doing. And that concludes this video, and I want to thank everybody for watching.